Hello friends, I am Veerbhadra Yadamaya, Managing Director of VBSM Academy. Come friends, let us discuss about the atomic models, atomic structure. You know, my dear friends, John Dalton 1803 discovered his atomic theory. Sir J.J. Thomson 1904 discovered his atomic model. Ernest Rutherford in 1911, Niels Bohr in 1913, and Erwin Schrödinger 1926, and Eugen Goldstein discovered proton. James Chadwick discovered neutron. The history of atomic models or the atomic structure has evolved over time with contributions from many scientists, my dear friends. The idea of atoms dates back to ancient Greek philosophers like Democritus. This is the image or statue of Democritus, who proposed that matter is made up of indivisible particles called atomos around 430 BCE. In the early 19th century, John Dalton developed the first model and the modern atomic theory, suggesting that atoms, different elements, vary in size and mass. However, detailed structure of the atom was discovered by Ernest Rutherford in early 20th century. He is great scientist Ernest Rutherford. His famous gold foil experiment in 1909 led to the discovery of atomic nucleus, establishing the Rutherford model of the atom, which consists of a dense positively charged nucleus surrounded by neutrons. Well friends, the atomic structure refers to the structure of atom comprising a nucleus at the center in which the protons positively charged and neutrons neutral are present. The negatively charged particles called electrons revolve around the center of the nucleus. Arrangement of subatomic particles within an atom. Nucleus, the central part of the atom containing protons and neutrons, together called nucleons. A nucleon may be a proton or a neutron. Protons are positively charged particles. Neutrons are neutral particles with no charge, and the electrons, negatively charged particles that orbit the nucleus in regions called electron shells or orbitals. These are the electron shells or the electron orbitals. This is the electron in the nucleus, proton and neutron, which are also called as nucleons, which are present in nucleus. Atomic number represented by the letter Z, the number of protons in nucleons, which defines the element. For example, carbon has an atomic number 6, meaning it has 6 protons. Mass number A, the total number of protons and neutrons in the nucleus. Electronic configuration, the arrangement of electrons in the orbits around the nucleus. Electrons fill orbitals in a specific order based on their energy levels. This electron configuration refers to the arrangement of electrons in an atom's orbitals. Configuration is crucial because it determines the chemical properties of an element. Basic concepts. Number 1, electrons are arranged in orbitals around the nucleus. Orbitals are regions where electrons are likely to be found. There are different types of orbitals, that is S, P, D, F. each with a specific shape and capacity. The electron configuration is written using the principal quantum number n and the type of orbital is SPDF. The electronic configuration of sodium, for example, 1s2, 2s, 2p, 6s, 3s1. Rules of filling orbitals, very important. Filling the orbitals, filling the electrons by orbitals, electrons, Aufbau principle. Electrons fill orbitals starting from lowest energy level to higher energy level. Pauli's exclusion principle, each orbital can hold maximum of 2 electrons with opposite spins. Hund's rule, electrons will fill degenerate orbitals with the same energy singly before pairing up. Abbreviated notation, for examples with many electrons, the electron configuration can be abbreviated using the nearest noble gas configuration or S2 physics configuration or stable gas configuration. Understanding the electronic configuration helps predict the behavior of elements in chemical reactions and placement in the periodic table. Well, friends, coming to the introduction to the Hund's rule. Aufbau principle tells us the lowest energy orbits get filled by electrons first. After the lower energy orbitals are filled, the electrons move on the higher energy levels or on higher energy orbitals. The problem, that is the demerit of the Hund's rule with this rule is that it does not tell about the 3 2p orbitals and the order that they will be filled in. According to Hund's rule, before the double occupation of any orbital, every orbital in the sublevel is singly occupied. For example, maximization of total spin. All electrons in a single occupancy orbital have the same spin. An electron will not pair the another electron in a half-filled orbital as it has the ability to fill its orbitals with similar energy. Many unpaired electrons are present in atoms which are at the ground state. If 2 electrons come in contact, they would show the same behavior as 2 magnets do. The electrons first try to get as far away from each other as possible before they have to pair up. Here, if you observe 1s, 2s, 2p. If you observe the 2p orbital, unpaired electrons. Next, electron configuration. So here Hund's rule of maximum multiplicity is a principle in the quantum chemistry that predicts the ground state of an atom or a molecule with one or more open electronic shells. Here is a concise explanation. Electronic configuration, for a given electron configuration, the term with the maximum multiplicity, that is the highest number of unpaired electrons, as the lowest energy. Orbital filling, electrons will occupy empty orbitals singly as far as possible before pairing up. This minimizes electron-electrons repulsion and maximizes the total spin. Spin multiplicity. The multiplicity is given by 2s plus 1, where s is the total spin. For example, if there are 3 unpaired electrons, the total spin s is 3 by 2 and the multiplicity is 4. This rule is crucial for understanding the electronic structure of atoms and molecules, especially in spectroscopy and quantum chemistry.